Okay, good afternoon, everyone. I am Sir Chris Rabi. I am your Science 9 teacher. And this afternoon, I will be discussing all about the third week of our Module 3, Properties of Ionic and Covalent Compounds. Lesson 1, Properties of Ionic and Covalent Molecular Compounds. At the end of the lesson, you will be able to describe the properties of ionic compounds. Specifically, after going through this module, you will be able to: number 1, identify what are ionic compounds and covalent molecular compounds. Number 2, distinguish the properties of ionic and covalent molecular compounds. Number 3, explain why ionic and covalent molecular compounds possess these physical properties. Before we proceed to our main topic, so let us have a quick review about the modern periodic table. So at present, we have a total of 118 elements in our modern periodic table. So this modern periodic table was structured and organized by Dmitry Mendeleev. So there are 118 elements in here, in which they are classified into three. We have the metals, the non-metals, and the metalloids. Okay, so there are six metalloids that we have. This color green here, so there are 6 metalloids or semi-metals, and then we have a total of 18 non-metals, the color blue, this one, hydrogen and all the blue in here, so they are considered as non-metals, and the rest in the periodic table are metals. Okay, so let's also review the different parts in each box of the element. So the number at the top is termed as the atomic number. The letter, usually there are 1 or 2 letters only that serves as the symbol. And we have the name below, and then we have the average atomic mass, in which if we round it off, it becomes the mass number. So example, for carbon, that is 12.011. So if we round it off, that becomes the mass number, that becomes 12. Okay, that is the mass number. So the atomic number is just equal to the number of protons and to the number of electrons if the element is not ionized. Okay, so excuse me, if they are not ionized, they are just equal: the number of electrons, the number of protons, and the atomic number. Then we have the mass number minus the atomic number. If we subtract the two, we will get the number of neutrons. So the 3 subatomic particles present in the atom. Okay. With regards to the arrangement, so this here, so kining mga vertical arrangement, kining nagbarog, the columns, these are termed as group or family. So we have 18 groups from here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the horizontal arrangement is termed as the series or period. So we have here 1, 2, 3, 4, 5, 6, 7. So this one here is just the continuation to period 6, and this one is a continuation to period 7. Okay, So again, the vertical columns are the groups or family, and then we have the horizontal or the rows are your period and or series. Okay, example. So determine the group number for oxygen. So that is group 16. From here to here, that is 16. How about the period for potassium? That is 1, 2, 3, 4. Period 4. Okay, so we have here the two types of compounds. First, we have the ionic compounds. These are formed between a metal and a non-metal. The chemical combination between the two types of the elements results in the formation of ionic bonds between the atoms. Ionic bonds are the electrostatic force of attraction that hold cations, positively charged atoms, and anions, or the negatively charged atoms, together. Sodium chloride is an example of an ionic compound. Sodium chloride, or commonly known as the table salt, kanang atong gigamit nga asin sa panimalay. So it is the combination of sodium, which is a metal, and chlorine, which is a non-metal. Sodium becomes cation Na+ as it loses an electron and transfers to the chlorine atom. So in here maka-form na ta og ions because sodium na siya valence electron nga 1. Di sampo na nato gikuha ng 1. So gikan na siya sa group 1 and 2, ang atong valence electron mag-follow rata sa group number. So group number 1 and 2. So ang group 1 na ay valence electron nga 1, ang group 2 na ay valence electron nga 2. And for groups 13 to 18, so to get the valence electron, just have to subtract their group number minus 10. So example, for chlorine, so it belongs to group 17. So it is 17 minus 10. So the valence electron for chlorine is 7. Okay? So sodium, naa siya usa ka valence electron. So ideal kanang usa niya ka electron iya na lang i-donate dito ni chlorine para ang chlorine mahimong stable according to octet rule. Kaya ang 7 kuwang usa para mahimong 8, satisfying the octet rule. So to get a stable compound, so it should have to follow the octet rule. Second is the covalent molecular compounds. These are substances that are formed from the chemical combination of two or more non-metallic elements based on figure 2. It could be between a non-metal and another non-metal, or a metalloid and a non-metal. So the covalent molecular compound is not possible for metals to metals or metals to non-metals. Table sugar or sucrose is an example of a covalent molecular compound. So, as we extract the table sugar, kanang kamay nga itong gigamit sa balay. So, carbon is a non-metal, hydrogen is a non-metal, and oxygen is a non-metal as well. In a covalent compound, atoms of different elements are held together in molecules by covalent bonds. Unlike ionic bonds, in which electrons completely transfer from one atom to another, the covalent bonds share the valence electrons. Okay, so kung ato i-compare kining duha ka bonds, asa kaya mas stronger? Okay, mas stronger ang covalent molecular compounds because they share. Oras managhigugmaay or manag-uyab. Kung unsay problema sa usa, i-share sa usa, mag-share sila. So, mas stronger ang ilang bond. Compared atong usa nga sigirag donate or ang usa sigirag dawat. So, if we compare the two bonds, the covalent molecular compounds or the covalent bond is stronger compared to the other one. Okay? Okay, so properties of ionic compounds and covalent molecular compounds. So ionic compounds form crystals just like in the table salt. So what is yung mga crystals? They have high melting point and boiling point, so it means they are hard to melt and hard to boil. They are hard and brittle. So gahi and then brittle or dali siya madugmok. They conduct electricity in aqueous solution. So once they are exposed uh, to an aqueous solution, so a solution wherein water is the solvent, so they could conduct electricity. They are non-conductors of electricity in solid form. And then properties of covalent molecular compounds. So they have low melting points and boiling points. So it means they are easily to melt and boil. So they are soft and flexible. They are flammable. So once exposed to heat, so they could uh, produce fire. So they are flammable. They are not conductors of electricity and they can be classified as polar or non-polar. So we have here electronegativity is the ability of an atom in a molecule to attract shared electrons toward it. Figure 10 shows the electronegativity values of the elements in the periodic table. So we have here the values of the different elements. So you need to subtract these values to get the electronegativity difference to determine the type of bond possessed by each compound. Okay, so inyo lang i-subtract. Then if you get a range, you can be able to determine what type of bond does it. Electronegativity difference to classify bonds. So these are the range. So less than or equal to 0.4, that is non-polar covalent. 0.5 to 1.9, that is polar covalent. And then greater than or equal to 2.0, that is ionic bond. Example, calculate the electronegativity difference and give the kind of bond that exists between the atoms in each pair. So for you to get the values for each element, you have to see figure 9, the one that I've shown a while ago. First example, we have calcium and oxygen. So the electronegativity value for calcium is 1.1 and the electronegativity value for oxygen is 3.5. So you have to determine the greater number that will serve as the minuend, ang number nga minusan. And the smaller number will serve as the subtrahend, ang number nga i-minus. So after that, you will determine the electronegativity difference. So the answer is 2.4. So therefore, ang answer nato is ionic bond because it is greater than 2.0. So the next part here will be shown to you in the next video. Okay, so let's proceed to the second example for the electronegativity difference to know what type of bond does the compound possess. Okay, so number 2, we have silicon and hydrogen. So the value for silicon, electronegativity value is 1.8 and for hydrogen is 2.1. So take note, you have to determine the greater value and the lesser value. So the greater value will serve as the minuend and the lesser value will serve as the subtrahend. So in this case, hydrogen will serve as the minuend. The electronegativity value for hydrogen, which is 2.1 minus 1.8. So the answer is 0.3. So it is less than 0.4. So therefore, this type of bond is non-polar covalent bond. Okay, number 3. We have oxygen and fluorine, O and F. Okay, so our fluorine has a greater value, so it serves as the minuend, 4.0 minus 3.5. So the answer is 0.5. So the answer the type of bond is polar covalent bond because it's greater than 0.4. Number 4, we have Br and H, bromine and hydrogen. So bromine is a greater value, 2.8 minus 2.1. So the answer is 0.7. So the type of bond is polar covalent bond. And then for the number 5, the last example, you have C and H, carbon and hydrogen. So carbon is greater than, so 2.5 minus 2.1. So the answer is 0.4. So making it 0 to 0.4, that is non-polar covalent. Okay, so these are our examples. So you know now how to determine the type of bond according to their electronegativity difference. Okay, so for ionic bonding, a type of bond that deals with the transfer of electrons. So let's have an example. So we have potassium and iodine. So potassium has a valence electron of 1 because it belongs to group 1. So it is represented by a Lewis electron dot structure. And for iodine, it has 7 valence electrons since it belongs to group 17. So again, as I told you in the earlier slide, so groups 13 to 18, you can get its valence electron by subtracting the group number minus 10. So for iodine, that is 17 minus 10. So the answer is 7. So that 7 is the valence electron for iodine. So we have 7 dots surrounding the iodine. So 1, 2, 3, 4. So ato siyang ilibot ang upat, una nato i-pairing. 5, 6, 7. So potassium has 1 valence electron and iodine has 7 valence electron. So our goal is to make that stable. Okay, so once that electron is being transferred, so there will be ionic bonding and an ionic compound will be formed. So ideally, according to the octet rule, in order for a compound to be stable, it must have 8 electrons. So ang atong buhaton, kini usara man ni siya, so ato rang ibalhin dito sa pikas so that the compound will be stable. So this one will be transferred here. So making that stable, then the two of them will become stable, forming the compound potassium iodide. Okay, so the formula for that is based on here. So once ang usa ka element mag-donate, so it becomes K plus. Once it donates, mahimo siyang cation or positive ion. And then the other one that receives becomes negative anion or the anion or the negative ion, forming the compound potassium iodide. Okay, so for carbon, it belongs to okay, so carbon belongs to group 14. So 14 minus 10 is equal to 4. So therefore, 4 is the valence electron for carbon. Then for hydrogen, since it belongs to group 1, so its valence electron is 1. So we have here carbon, and then we have 4 hydrogens. Okay, so for that to be stable, dapat ang carbon na siya ay 8 valence electrons. Helium and hydrogen is an exemption to the rule. So, para mas stable sila, okay, so for it to be stable, ang hydrogen o ang helium plus, ilahanglan ra og duha ka electrons para mas stable. Exemption sila sa octet rule. Okay, so let's surround each element with their valence electron. So hydrogen, usa po diri, usa diri, o usa po diri. Carbon na siya upat. 1, 2, 3, 4. So let's connect the dots. Okay. So therefore, if we count, the carbon now has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Making it stable. Then hydrogen is stable as well. The 4 hydrogens are stable. That is all about covalent bonding.